Hi, we from Group 5 will present and explain the operation mode under counter mode. Introduction. The counter mode or center is a simple counter-based block cipher implementation. Every time a counter is combined with nonce, is encrypted with the key, and given as input to XOR with plaintext block with results in ciphertext block. The center mode is independent of feedback use, thus can be implemented in parallel. Counter mode is only suitable for stream cipher, as stream cipher breaks a plain text message down into single bits, which then are converted individually into ciphertext using key bits, as a block cipher breaks down plain text messages into fixed size blocks before converting them into ciphertext using a key. Can considered as a counter-based version of CFB mode without the feedback in this cryptography. In this mode, both the sender and receiver need to get access to a reliable counter, which finds out a new shared value each time a ciphertext block is exchanged or changes the value which is shared. This shared counter is not necessarily a secret value, but the challenge is that both sides must keep the counter synchronized at a time when both are active. Process. Both encryption and decryption in center mode are depicted in the following illustration or steps. Firstly, load the initial counter value in the top register is the same for both the sender and the receiver in this mode. It plays the same role as the IV in CFB and CBC mode similar way. Then, encrypt the contents of the counter with the key and place the result in the bottom register in this mode. Then, take the first plaintext or original text block P1 and XOR this to the contents of the bottom register. The result of this is C1 as ciphertext. Send C1 as ciphertext to the receiver and update the counter in this mode. The counter update replaces the ciphertext feedback in CFB mode like no feedback required. Continue in this manner until the last plaintext block has been encrypted. Thus, decryption is the reverse process. This ciphertext block is XO-read with the output of encrypted contents of the counter value of shared. After decryption of each ciphertext, the block counter is updated as in case of encryption in the cryptography. Encryption and decryption. For encryption, the counter is encrypted and then XOR with the plaintext block to produce the ciphertext block. For decryption, the same sequence of counter values is used, with each encrypted counter XOR with a ciphertext block to recover the corresponding plaintext block. The advantage of counter mode is pre-processing. When the plaintext or ciphertext input is presented, the only computation is a series of XOR, greatly enhancing throughput. Random access. The block of plaintext or ciphertext can be processed in random access fashion. Provable security. Center can be shown to be at least as secure as the other modes. Hardware efficiency. Encryption, decryption can be done in parallel on multiple blocks of plaintext or ciphertext. Software efficiency. Processes that support parallel features can be effectively utilized. Simplicity. Requires only the implementation of the encryption algorithm and not the decryption algorithm. Disadvantages. Decreases of synchronization lead to the incorrect recovery of plaintext or original text. Lack of authentication. Like all unauthenticated encryption modes, the bare counter mode lacks integrity and authentication. A single bit of flipping can have catastrophic results due to the malleability of the counter mode. Message length. Usually, the message length is not considered secret. There are approaches that you can add random values to the end or beginning or both if this is really an information leak for you. The random approach depends on your actual data case. It is also possible that a predetermined fixed size can be used, as the email can be limited to 512 characters. In the end, at least the upper bound is revealed in all of the cases.